In our voice today, we will be exploring dark matter. No, it is not matter that appears dark or some fragment of science fiction. It actually exists. Everything you've ever seen, all the matter we know, which makes up all stars, galaxies, and us, only accounts for 5% of the content of the universe. Dark matter makes up around 27%. But what is dark matter in the first place? Dark matter is like normal matter, as it has mass and so it interacts with the force of gravity. That's all that is similar about matter and dark matter. It is very different, as it doesn't interact with light. So we can't see it, but we know it exists. Imagine seeing a dandelion fly. We know it flies because of the wind. We can't see the wind, but we know it exists because of the effect it has on objects and surroundings that we can observe. In a similar manner, dark matter, though can't be seen, exists because it interacts with the force of gravity, and through that, with other objects. Dark matter is responsible for holding together galaxies, and this discovery accounts for the confirmation of dark matter's existence. When galaxies rotate, they rotate at such high speeds that the gravity generated by the observable matter could not possibly hold them together. They should have torn themselves apart. But we still have galaxies and live in one. So, how is it possible? This observation was present in all the galaxies. There was simply more mass than we can see. Scientists thought that it must be some unknown matter or dark matter in these galaxies causing them to have this extra mass, which generates the extra gravity they need to stay intact. It was observed that there was more dark matter in galaxies than normal matter. You might have known that objects orbiting a large distance from a massive object will move more slowly than objects that are closer to that central mass. Like in our solar system, for example, the outer planets like Jupiter move more slowly in their orbits than the planets close to the Sun, like Mercury. But our observations demonstrates that the farther away we get from the massive object, like the center of the galaxy, the faster the object's orbit. If the galaxy only had the mass calculated through the light seen, then the high-speed outer objects should have long ago escaped, because if an object moves fast enough, it should escape the pull of gravity. Yet, this is not observed in galaxies, meaning they must have more gravity than can be supplied by the luminous matter. In fact, a lot more gravity. We know dark matter exists, but what is it made of? Dark matter is matter that doesn't interact with the electromagnetic spectrum, meaning it doesn't reflect, emit, or absorb any wavelength of light. Visible light, microwaves, radio waves, nothing. There is no way for us to see it. But we assume that it is composed of exotic subatomic particles of a type not yet detected on Earth. Does this make you curious to know what the rest of the universe is? Then don't forget to subscribe to this channel as it is your ticket to our next voyage, where we will be exploring dark energy and string theory. Buckle your seatbelt because we are just beginning our voyage. See you next time.